All right, welcome ICS3U folks. What you're looking at right here is my version of my SDLC, and yours is going to look a lot different, and that's good. It should look a lot different. I'm just going to talk about a few things. I'd like you to, anything that you see on my website that you didn't know or you didn't come across in your reading, you should add to your notes. You don't necessarily have to add them to your web page, but you should add them to your notes. Certainly, one thing you might want to do is have this handy, and I'm hoping that well, this link is pretty bad, but I'll show you how to get to this my software development life cycle web page. From our home page, you go in here and there should be a folder. There's all the files, and it's kind of a mess. It shouldn't look like that, but oh well. Then you click on, if you click on this one, the Restalls SDLC HTM, that's my website, my web page. And I'm going to blow it up just a little bit so you can read it a little bit better. There are some things that I want to mention, and again, your names are going to be different. I've got my web page has got a few fancy things to it. I can move up, and you don't have to do any of that. It's the content that I'm talking about now. There's my picture I drew in, I think it was paint. You should have something along the line of your software development life cycle. I've called my earliest stage just problem, but you could call, I don't know what you called your first stage, but it's this idea of we've decided that we want to make some sort of software. And so how do we go? What do we do? The purpose. We identify the need. So what's the problem we need to solve, or what's the need in the market that we need to fill with a new program? We define the problem, we define the project scope and objectives, and we allocate resources. Allocate resources means like people and money and time. Define the project scope and objectives. And again, remember, this is about huge projects. And we'll take some of this problem definition forward for our purposes, but this is usually more common in huge projects. So start identifying possible solutions, discuss alternate solutions and their relative strengths and weaknesses. So I don't know what you called your first stages, but this would be one of the early stages. And I'm going to show you some of the possible deliverables. And again, you don't have to copy these ones, but I'll tell you which ones will be important. The feasible study. This is an outline. So this would be a huge document, and I'll show you an example of that in a second, that sort of addresses each of these issues. And so if a big company wants to enter into some sort of software development, they'll want to address all these things just to decide whether the project is feasible, whether it's worth it financially, or whether whatever they have now is going to suit them. So here's an example. And hopefully these links work wherever you are consuming this. You can see this feasibility study, and this is some company, and I pinched this off the internet, but I don't think it's too big a deal. I just want to show you the size and scope of this. This is, no software has been written yet. This is just the idea of trying to decide whether a company will take a project on. That's what a feasibility study is. Not doing it. A project charter is very similar, and this is actually a skeleton that you could use to fill in, but you see all the different things. 9 pages. This is 9 pages of stuff, and nothing's filled in yet. Nothing's filled in. This section, a company would fill this in, or I think this is from the British Columbia, the government of British Columbia. If you wanted to do something for the government of British Columbia, that you'd have to fill out one of these project charters, and it's got all these, and this has got to do with this. It says the following table's content is meant as an example and is not complete, But you see there, this is kind of their software development life cycle, and the description and the target dates and so on. And it says that it's huge, and we're not doing it. Okay, but I want to expose you to the idea that a lot of effort goes into these early stages. Things that we will do and we will see soon in the problem stage are Gantt charts. There's a Gantt chart, and what that means, don't worry about it yet, but we'll see that. And here's another Gantt chart, another Gantt chart. Gantt is named after a person. A PERT chart, and all of these links work, so you can look at them in more detail. Program evaluation and review technique is what PERT chart stands for. I'm going to close some of these down just so I don't have a million pages open. We will construct some Gantt charts and PERT charts. Certainly, the problem definition table and IPO chart are things that we will fill out as well. This is more for programs that are our size, and essentially this is just for you to get an idea of what the problem is. Okay, problem definition. And IPO chart, well, we're used to this IPO business already. So input, processing, and output. I think these files, if you wanted a copy of these, this is a PDF, but you could just save as. I think even Google Docs will allow you to read in a PDF, and certainly if you wanted that, you might be able to just copy and paste it. Pretty easy to make your own IPO chart as well. Okay, that's the problem phase, and I'm going to go quickly through the next few stages. The reason why I wanted to talk about the problem phase in such detail is kind of that's what's coming up next. But I wanted to show you some of the things, other things that I included in my my web page. The design phase, I couldn't find any more names for that, but the purpose is to generate all planning details, how the selected solution will be implemented. So how, what steps are we going to do? No specific programming language or development package is selected yet. So we haven't decided whether we're going to program this in Java or JavaScript or HTML or whatever it is. Possible deliverables. And these we're used to. We're used to flowcharts and pseudocode. And I think we're used to pseudocode, certainly flowcharts. And we are going to write some more. And we've seen this when we were talking about how things like loops and decisions, what it looks like picture-wise. Pseudocode is English-like instructions, and we'll get some practice writing pseudocode. So it's, this is in Fortran, Pascal, and C style. These are all specific to a certain language. It's not supposed to be typical of a certain language. It's supposed to read almost like English, almost. Prototypes. Hopefully some of you came across the idea of a prototype when you're doing some investigations on your SDLC. A prototype, simplified versions, partial programs, sample input and output screens or reports. Basically, this is what the software will look and feel like when it's working without much of the details filled in. Part of the design process, we can talk about top-down design, where the design is from more complicated procedures to more specific. So we think of the big picture and break it down into smaller pieces. Bottom-up design, specific requirements are defined and the program is designed to meet them. So in this case, we'd say, okay, we need a program that does A, B, C, D, E, F, G. We need it to do all these things, all these details first, and then we figure out how to put them together into one program. All right, and that's design. We will practice flowcharts and pseudocode later. Coding, that's what we've been doing all this year. This is it, right? This is what we've been doing, coding. And there's other names for it. I think the favorite for Wikipedia is implementation, but I've kind of split implementation into my next step. And yours are going to be different, I realize that. Actual code's written, user feedback can alter details, but not the overall design. So you start coding, you've got like your You've got your plan in motion, and you can't sort of change everything at this stage. The design's already done. Documentation, internal and external, is produced. Internal documentation, that's in the code, the documentation itself. External are things like help files and manuals and stuff like that. And we'll get a little practice at that, not much. Delivery. Um, and we'll get a little practice at the last couple of stages, and you might call this a different thing again. Implementation, installation, conversion, whatever. The purpose, the old system is replaced by a new system, or a new system is introduced to users. That's the delivery, and the training takes place. And I wanted to mention, and you probably haven't read this, but these are important things. The conversion process, direct conversion, is on a specific date. The old system is thrown out, and then the new system starts. So it's bang, one ends, bang, the other one starts. Parallel, on the other hand, is for a period of time, both systems are used to ensure the quality of the new system. So you're running the old version and you're running the new version and making sure the same stuff is happening. Phased, a new system is introduced a little at a time and the old system is archived a little at a time. So here's the picture that compares them. I hope, oh, not there. Oh, that's too bad. I wonder why not. I'll see if I can get this fixed before I actually upload this video. Hopefully you'll be able to see that somewhere. The last thing, upkeep, also called maintenance. The system's used on a regular basis, and bugs and changes are fixed and documented in a structured way. This is the idea of, your Java wants to install some updates, or iTunes wants to download a new version, or iOS. These are all, something's happened, and there's a bug or a new feature, and you want to add to the old program rather than starting a new program. I called it upkeep, I think, just because it's a lot shorter than the word maintenance. Okay, that's all I wanted to say there. Hopefully you've had a chance to add bits and pieces to your notes. You don't necessarily, please do not just copy all my stuff and put it into your web page. That's not the purpose here. The purpose was there's a few definitions I want to make sure that you're aware of. So even though it's not on your web page, these details should probably be in your notes somewhere, or at the very minimum, a link that you copied into your notes so that you know to look to my notes when you're studying for this, for a quiz or a test. All right, that's all I have to say about that. Next up are some problem definitions, Gantt charts and PERT charts.